4 or 5 complete the square. So this is another way to solving quadratic equations. So it's another way to solve a quadratic equation. Now this way, the benefit here is that it always works. It won't always be pretty, but it always works. So let's talk about the kind of setup. So first, if I want you to multiply x plus 3 squared, the way we do that, we do not, remember, do not do this. This is not true because it's a binomial, right? You don't, that's not how you do binomials. What you do is you multiply by itself. The plus sign messes it up. You can't do it that way. So you multiply these together, that together, you get x squared plus 3x plus 3x plus 9. So you're going to get x squared plus 6x plus 9. If you do this one, let's do this one first. X minus 5 times x minus 5. If you're a little faster, okay, it's going to be x squared. It's going to be the two middle ones plus 25. So you kind of notice a pattern if you do this enough, and you're like, wait, it's always the last one squared, and it's always like two times this one to be the middle, right? It's like 3, it's a 6, it's a 10. So this one should just be first one squared, multiply them together, negative 6 and times it by 2, negative 12w plus 9. Like if you actually multiply it out, right, you get that one, you get 4w, then you're going to get 6w plus 9. So it's a little shortcut. In general, if you start noticing like the little shortcut, honestly, I don't do it. I just multiply it out because it's faster for me. The general idea is supposed to be this. It's called a perfect square trinomial. If you have a plus b squared, it's just going to be the first one squared, the second one squared, and then 2 times multiply them together. And actually, what I use it for more is a factor. If I see this, I'm like, wait, that's squared, that's 2 times these, then it's just going to be x plus 1 squared. That's going to be p minus 9 squared. This right here is a tougher one. That's a square, and that's a square. This is 12. This is 2. 2 times 12 is 24, and that's double. So yeah, that works. 2y plus 12 squared. That's all that is. It's just saying, noticing, hey, it's in that form. It's a perfect square trinomial. So we like perfect square trinomials because they factor perfectly like this. And why do we like that stuff? Well, because they're easy to solve. That's the next part here, right? If it's a square, all we have to do is square root it, and I get x is equal to plus or minus square root of 121, which is plus and minus 11. Same thing here, square root it. X plus 3 equals plus and minus square root 36 is 6. I'm going to have two answers. I'm going to have x plus 3 equals 6, and x plus 3 equals negative 6. So subtract 3, x equals 3, minus 3, x equals negative 9. You should always have two answers on these. If it's squared, it mean you should have two answers. So that's how you solve this one, right? Same thing here, square root both of them. X minus 2 is equal to plus and minus rad 3. Anytime you square root, it's plus and minus. Now here, I don't know what the rad 3 is. I'm just going to leave it. So when we add 2, I'm going to add 2 on this side. And my answer is going to be 2 plus or minus rad 3. That's actually my favorite one because it's a lot less work than actually having to solve it out. You can't do anything there, so you just leave it like that. Like, okay, that's all good and great. What about the perfect square thing? That's what this is right here. If you notice, so you know how I normally say set equal to 0 and factor? But if you notice, there's like one caveat to that. If you notice it's a perfect squared, you can just factor it and you get this. This is x plus 6 squared equals 6. Now, hey, there's only one variable. So remember, there's one variable, just solve it. Subtract the 6. So there's that, right? So there's always two ways to solve this. You could set equal to 0 and factor, if it factors or if it doesn't. Or, if you notice it's a perfect squared, factor it, and then you just have to square root and solve, because now you only have one variable. Same thing happens here real quick. Right? Oh, it's the perfect squared. X minus 4 squared equals 13. Now you can square root it. X minus 4. What am I at? Okay, x minus 4 equals plus and minus rad 13. Add 4 to both sides. X equals 4 plus and minus rad 13. Right, so it's actually, if you notice it's a perfect square, it makes solving pretty easy. Like even this one, it looks disgusting. But if you notice, wait, that's just a perfect squared. That's 3 squared, that's 5 squared, and if you 15 times 2 is 30, so it works. It's 3x plus 5 squared equals 11. If you notice that, then you just solve it. And then you subtract 5. And divide by 3. Almost forgot about that part. I was like, oops. So you get that as an answer, right? So you get a big old mess like that. But that's the benefit of having a perfect square. So if you know it's a perfect square, you can just factor it. Instead of saying equals 0, you can just factor it and then make it. You just factor it and then just solve. So what if it's not a perfect square? That's what the title of this lesson is. Then we can make it a perfect square by completing the square. So if it's not a perfect square, we can make it a perfect square by completing the square. And the key to doing that is this. You want to add, well, we'll get to it. I'm going to show you 2 ways first. I mean, they're both the same thing, but let me show you the basic way. So if we have this. So if we want to complete the square, first thing you want to do is you want to isolate the x squares. Get the x's by themselves. So get rid of that c. So it'll be like this. X squared plus bx equals negative c. And then what we do is this. Here's the key part. We do it's called the complete the square step. We're going to get the middle term. We're going to divide it by 2 and square it. That's where you're going to add to both sides. So that's how you complete the square. And once you do that, then you have a perfect square. So the key thing is isolate the x's, and once you isolate the x's, you're going to add b over 2 squared to both sides. And now to me, what the thing you get back is going to be a perfect square. So in this case, it's going to look like this. And then this thing is a perfect squared. And the trick to that, it's always the thing before you square it. It's always this. And that's a little messy, but we'll do a couple examples and it'll make more sense. And I'm going to come back to this side to talk about what happens when it's a little bit tougher. So it's a little messy, but the general idea is get the x's by themselves. Once you do that, the key step is right here. I cannot mention this enough. You're going to add this to both sides. Add b over 2 to both sides. So that's what they want right here. Just, hey, what would make this a perfect square? That's all this part wants. So we get the b get the b term, divide it by 2, and square it. So negative 10 divided by 2 is negative 5. Squared is 25. So this should be a 25. I want it to be a perfect square. Same with this one. All I want to know right now is how to make it a perfect square. So this right here is a perfect square. How we do it? All we do is get the middle term, divide it by 2, and square it. So in this case, I get square both of them. I get 25 over 4. And that's how we do a perfect square. And actually, I'm going to go a little further. How do you factor that? Well, if it's a perfect square now, like this, you can probably it's a little easier to look at it. Okay, what 2 things multiply to get 25? I had to get 10. X minus 5, x minus 5. It'll be x minus 5 squared. And that's the trick. If you want to factor it, it's always the thing before you square it, every single time. So in this one, if I want to factor it, I know it looks disgusting, but all it is x. And it's a thing before you square it. That's a perfect square up. That's the factor form of this. So let's do an example. Because I don't think I've been doing a great job, so let's try to do this. Hopefully make it up for it. So here, let's solve this. Right? Again, for step 1 is try to get the x's by themselves. So let's move over to that 8. So now we want to complete the square. So all we do is get the middle term, divide it by 2 and square it, and that would be 1. So what we're going to do is we're going to add 1 to both sides. So plus 1 and plus 1. On this side, I could factor it now. Now, again, it always factors. It's made to be factored. That's why we complete the square, because it has to factor now. And the trick is it's always a thing before you square it. In this case, it's x plus 1. 2 divided by 2 is 1. On this side, a plus 1 is 9. So you get that. Now we just solve it like normal, square root it. X plus 1 equals plus and minus 3. So we have two equations. X plus 1 equals 3. X plus 1 equals negative 3. Subtract 1. I get x equals 2 and x equals negative 4. And that's how you solve by completing the square. So that way it works. Now, another way of doing this one would have been just actually what we talked about earlier, where if you just look at the beginning and just factor it, that factors to be x minus plus 4, x minus 2. Splitting it gets you x equals negative 4 and 2. And you're like, well, that was a lot faster. It is. Factoring is generally the fastest way of doing it. The benefit of completing the square is that it always works. And let me show you what I mean by that. Let's look at the next one. This one, you cannot factor. Right? If you look at the factors of 9, it's like 1 and 9 and 3 and 3. None of those things add up to be 4. So you cannot factor this one. We're going to have to do complete the square because it always works. So let's complete the square. So remember, step 1, look at these x's by themselves. So x squared minus 4x equals negative 9. Then we get the middle term, negative 4. We divide that by 2, and we're going to square it. So I get negative 2 squared, or 4. And that we add to each side. So we're going to add 4 here and 4 here. Now remember, this side should factor perfectly. So the whole reason we do this. So that's a perfect square. It always is, and it's always a thing before you square it. So it's going to be x minus 2 squared. Over here, that is negative 5. So I have this problem. Now I got to solve it, right? There's only one x. We're just going to isolate and solve. So we're square root both sides. And I get x minus 2 equals, now a couple of things here, right? Plus and minus. And you can pull the negative out. So plus and minus I rad 5. Then we just get the x by itself. We're going to add 2 to both sides. So x equals 2. Remember, you can't combine with these because they're different. I rad 5. There you go. Those are two answers. 2 plus I rad 5, 2 minus I rad 5. And again, there's no way you can get that by factoring. The only way to get this is by completing the square and doing another method we haven't learned yet. So that's why completing the square is so important, because it always works. It's one of the 2 ways that always works. The next one's very important because there's a number in front. Now this one actually could divide everything by 2, make it easier, but let's talk about what to do with the number in front. So for that, I gotta go back to the very beginning. I'm gonna talk about what to do with the number in front. So if there's a number in front, how does that change things? Well, there's one very important thing to do if there's a number in front, and that is you can't have it. You gotta divide everything by that a. You need to have x alone. I shouldn't say alone, but like with no number in front of it. So you must divide everything by a. Or divide, factor out an a, whatever you want to say. Either way it works. So in this case, I would factor out an a. I get x squared plus b over ax equals c. You can also divide it by a, but I'm actually going to do, there's some problems where you want to keep the a on the outside. That's why I'm focus mostly on just factoring out the a. So if there's a number in front, sadly, you got to factor out the a first to make your life a little easier. And then now it's just like everything else. You can square the middle term divided by 2 and so on. I cannot stress that enough. If you have a number in front, you can't do it. You gotta get that a out of there. So let's do a couple examples with a number in front. So with this right here, so let me move the 12 over. I'm gonna get 2x squared plus 6x equals 12. And then we're gonna factor out the 2. It'll be like this: x squared plus 3x equals 12. Now we're gonna complete the square. So get the middle term divided by 2. Oh, that already kind of sucks, but whatever. So I'm gonna get 9 over 4. I'm gonna add that to both sides. Now, this is also another important part. I'm gonna add 9 over 4 here. Now on this side, that's actually incorrect. I can't just add 9 over 4. Very specific reason why I can't. Look what's going on here. You add 9 over 4, and it's getting multiplied by a value of 2. So on this side, you actually gotta multiply 2 times 9 over 4. Because there's a number on the outside that affects your answer. So you get that. Over here, we just solve it. Remember, that always factors perfectly. It's always the thing before you square it to be 2x plus 3 over 2 squared equals, this is not going to be pretty. That's the same thing as saying 9 over 2 So 4.5. So 16.5. Now it's just a math problem. Almost all of the way, but it's the same idea. Divide everything by 2. X plus 3/2 squared equals 8.25. Then I square root it and subtract 3/2 from both sides. Solve for number and space, but that's the idea. So that's what I do with the number in front. And we'll do a couple more just to show you. I'll skip that one because of space. Let's do this one. So we'll do this one to show you the same idea. How do you deal with the number in front? Right, so step 1, get rid of that 2. 3x squared plus 6x equals 7. And then from here, gotta factor out that 3. So pull the 3 out, because I have to have the x squared by itself if I'm going to complete the square. Again, there's more ways to do this, but if you complete the square, you have to have the x by itself. Next, you get the middle term and divide it by 2 and square to complete the square step. So I get a 1. I'm going to add a 1 here. And on this side, I can't add a 1 because it's 1 being multiplied by 3. So on this side, you want to add 1 times 3, or just 3. So that's the hardest part of that. Now we just simplify this. That's always, remember again, it's always a thing before you square it. So it's x plus 1 squared. It's a 3 on the outside. Over here, 7 plus 3 is 10. We have that. Sadly, it doesn't get any easier. Still ugly. Divide by 3. X plus 1 squared equals 10 over 3. Square root it. X plus 1 equals plus or minus, add 10 over 3. And then subtract 1. X equals negative 1 plus or minus, rad 10 over 3. Yay. We have, again, sometimes it's going to get ugly, but that's kind of the way to do it. So that's completing the square. So remember, key things to keep in mind, always have to have x squared by itself. So if there's a number in front, you got to factor it out. The way you complete the square is by taking the middle term divided by 2 and squaring it. That term right there, that's so important. And once you do that, it's automatically factorable. That's the whole reason we do this. So after you do that, it's always a thing before you square it to make it a factor. Let's do a couple application problems and then we're going to be done. So it's this first one here. Laser light show. The area in square feet of a projected laser light shown is given by this, where d is the distance from the laser to the screen, and at what distance will the projected light show have an area of 100, wow, I can't talk. Have an area of 100 square feet. So let's talk about it again, right? We have this formula here. Keep in mind you want to know what A and D do. So A is the area, and D is the distance from the laser. And look what they give us. At what distance will the projected laser light show have an area of 100 square feet? Again, I could read. So they're saying the area is 100 square feet. And this is in square feet. So A is 100. They want me to find the D. So 100, the distance. It's 0.16 D squared. All we gotta do is solve for the distance here. No need to complete the square here. Just divide by 0.16 and square root it. That was an easy problem. I'm not actually going to get the answers because I need a calculator for it, but you get that. Keep in mind this is distance, so your answer is actually only going to be positive. There's no such thing as a negative distance. Okay, one last problem. Another application problem. A fireworks distance d meters on the ground is given by this formula, where t is the number of seconds after the firework has been lit. So keep in mind again, we always want to know what the variables do. So d is distance from the ground. It's like a height essentially. And then t is time after fireworks have been lit. So let's look at the questions. A, how many seconds have passed since the firework was lit when the firework explodes? If it explodes at the maximum height of the graph. So maximum height, remember the way we find that is the vertex. Right, vertex gives you the value on the vertex is the max height, max or min height, and then h is when it happens. And this one says how many seconds after, so they're actually looking for the h. They just want to find the vertex. What is the height when it explodes? So they want to find the max height there. So the key to this whole problem is just find the vertex. Now this actually has nothing to do, it's more of a review problem. We should remember how to find the vertex, right? It's super important. The way we find the vertex, the way you find the x value is negative b over 2a. Kind of similar to the complete square formula, but it's different, so keep that in mind. I will give you this formula for axis symmetry. So that's how you find the x and the vertex, and you just plug it in and find the y. So if I have this formula here, here's my a, here's my b. A is always a thing squared, b is always a linear term. I get negative 25 over 2 times negative 1.5 to negative 25 over negative 3, which does not go in nicely because you know life isn't fair. 8 1/3 seconds. So it takes 8 1/3 seconds to reach the max height. Now they actually want to find the actual height when it explodes. Just plug in 8 1/3 seconds. So D equals negative 1.5 times 8 1/3 squared plus 25 times 8 1/3. Plug that into a calculator and you get an answer, and that's the max height. So there we go, and that's it for complete the square.